Hi everyone, welcome to this video. We're just going to do a couple of quick examples on Introduction to Matrices. So we've got worked example 1, indicated up here. So we've got for each of the following matrices, give the order and appropriate name. So let's start with that. So we've got matrix A. So matrix A, so what's the order of the matrix? Well, we've got 3 rows, 3 columns. So matrix A is going to be a 3 by 3 matrix. It asks to give the appropriate name. So because the rows and the columns are the same, we can say it's a square matrix. Where possible, write the 2, 1 element. So 2, 1. So where's element 2, 1? Well, second row, first column, so it's 0. And the position of the number 3. So you've got number 3, so it's in the first row, first column. So number 3 is in the first row, first column. Now let's go to matrix B. So the order, we've got 1 row and 3 columns, so it's a 1 by 3. So because we've got a 1, it indicates that we've got we only got 1 row, so it's a row matrix, so that's the name. The 2, 1 element, well, second row, well, there is no second row, so it doesn't exist. And the position of the number 3. So number 3 is in the first row and we're in the second column. So first row, second column. Matrix C. Yeah, so we've got 2 rows, 2 columns. 2 by 2. Again, we've got a square matrix. The 2, 1 element, so second row, first column, so A 2, 1 is equal to 0, 0, and it's asking for the number 3. Well, there's no number 3, so we don't need to worry about that one. Matrix D, we've got 3 rows, 3 columns. Again, another square matrix. It's asking for, so the second row, first column, so second row, first column, we get the number 7. And number 3 is in the third row, third column. So number 3 is in the third row, third column. And last one, matrix E, is another 3 by 3. And the second row, first column, is another 0. And number 3 is in the first row, third column. First row, third column. So that's all we need to do for that. I will just note though, matrix A, it is a square matrix, but it's also a diagonal matrix. Okay, because we've only got numbers along the diagonal, all the rest are zeros. Matrix C is a square matrix, but we've only got 1s and 0s. So it's actually a special matrix, and I haven't mentioned this, it's binary. It's a binary square matrix because we've only got 1s and 0s. So binary matrix is only a matrix with 1s and 0s in it. Matrix D is a square matrix, but if you have a look, we've got 7, 7, -5, 4 and 4. and different numbers along the diagonal, but either side of the diagonal, it's symmetrical. Okay, and matrix E is a, should have written that in, square matrix, but we've only got numbers along the top half of the diagonal, all the rest are zeros. So it's an upper triangular. Okay, so just a special case of each of the different types. So that's work example 1. We'll just have a look at work example 2. So, work example 2, generate a matrix to show the number of major community roads between 5 nearby towns in the network shown. So we've got 5 towns, 1, 2, 3, 4, 5, and we want a matrix that represents that situation. So, because we've got 5 towns, we'll say it's going to be a 5 by 5 matrix. So here's town 1, 2, 3, 4, and 5, and 1, 2, 3, 4, and 5. So how many ways can we go from town 1 to town 1? Town 1 to town 2. Well, there's one path. So town 1 to town 2, there's 1. And town 1 to town 2, there's 1. Town 2 to town 1, it's the same thing. So town 2 to town 1. Alright, so it's going to be the same number in both cases. We also have one from town 1 to town 4. So we probably should be going rows by columns. So the first one, town 1 to town 4, well, there's one way we get there. And then going backwards, town 4 to town 1 is 1. So that's all the different paths for town 1. Let's move on to town 2. First thing to notice, there's a bit of a loop here. So it's saying town 2 to town 2, town 2 to town 2. We actually have 1, meaning a loop. And town 2 to town 1, I've already done that. Town 2 to town 1. Town 2 to town 4, 2 to 4. There's only one way we can get there. And town 2 to town 5. And again, there's only one way. And town 2 to town 3, there is no way. And I should have done zeros in here as well. Okay, so from town 1 there was no way to get to 3. There was no way to get to 5, and we don't have any loops. Moving on to town 3. Well, we can't go from town 3 to any other places, so that's all going to be zeros. Town 4, I can go to town 1, which I've already put in. Town 4 to town 2. 4 to 2, there's one way I can get there. Town 4 to town 3, there's no way. 4 to 5, I actually have 3 different ways. And there's no loop in town 4. And town 5, I can go from 5 to 4, 3 different ways. 5 to 2, I can go 1. I can't get to 3. Sorry, that should have been a 3 in there, and that should have been a 0. Sorry, so from town 5 to town 1 there's no direct route, and then 5 to 5 we have 0. Okay, so that's just making a matrix. Systematically, just start with your towns on each side, as I was doing in the example. Part B, generate a matrix to represent the following contingency table for party preferences of females and males. So this is a different example. Part B is for this table here. So part B. So we've got party preferences, Labor, Liberal, male, female, and the total down the bottom. So basically, it's just this matrix in here. Okay, so we've got male, female along the different columns, and 18 females prefer Labor, 16 prefer Liberal, and the total is 34. And then for males, we've got 12, 11, 23. So that's all we need to do for part B. Part C, generate a 2 by 2 matrix to represent the information in the following scenario. Omit the totals from your matrix. So we're only looking at this part here. So it'll be 18 prefer Labor, 12 prefer Labor for the males, females is 16 for Liberals, and 11 for the males. Sorry. Just going back a step. Part C. Is actually. It's just how I've drawn out the table. Part C is actually related to this information here. Not the table. So table belongs to part B. Part C belongs to this information here. So just finish this off here. So in a survey, 139 women and 102 men were asked whether they approved or disapproved of the proposed freeway. 37 women and 79 men approved the freeway. So we need a 2 by 2 matrix to represent the information. So again, we've got females and males along the columns, and we'll say approve, and disapprove. So from the information, we can say 37 women approved. So we can say 37 in there, and 79 approved for men. So 79. Oops. Okay, but in total we had 139 women, which means we need a 102 in there. 102 plus 37 gives us 39. And then the remaining men should be 23. 23. Okay, 23 men disapproved of the freeway. Okay, so that's part C. So that's all for example 2. Have a go at the questions. And ask for any questions. Thanks.